Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 1004, max consecutive ones 3. This is a medium difficulty Leetcode problem, and the problem description tells us that we're given a binary array nums and an integer k, and we want to return the maximum number of consecutive ones in the array if you can flip at most k zeros. So we're given, again, a binary array of nums and an integer k, and we want to return the maximum number of consecutive ones that we can flip at, in the array if we can flip at most k zeros. So the first kind of way I would understand this problem, and what I did was said, let's take out this requirement, so if we can flip at most k's. And how would we do this if we can only look at consecutive ones? Well, we'll just do a sliding window, wouldn't we? And we just do a simple sliding window technique. And strangely enough, it also works even when we have this requirement where we can flip at most k's, because we basically just factor that into our sliding window. So, instead of closing our window when we get to 0, we will just factor in the fact that we have k, so we'll treat any zeros under the k threshold as ones. So that's going to be the way we approach this problem. And we're given an example here, or two examples actually, which are quite helpful, because we can see here where k is equal to 2. And so we can flip these two zeros at these positions to 1, which will give us the longest subarray of consecutive ones. So it'll make a lot more sense once we actually start coding this up. I think with a lot of these kind of sliding window Leetcode problems, understanding the code is a key way to understanding the problem as well. So let's actually hop straight into the code. So the first thing we want to do is set 2 pointers, our left pointer, our right pointer. This is going to be the pointers on either end of our window. And we want to have a max, let's just call it result. Result is going to be equal to 0. And we want to say while r is less than or equal to, while r is less than or equal to the lump of nums minus 1. Let's, if we want to, before shifting any pointers, we want to check if nums r is equal to 0, we're just going to do k minus equals 1. So we're going to use our allowance of k, and we're going to treat the 0 as a 1. If we get to any condition where k is less than 0, so we've used more allowance than we're allowed to, well, the first thing we want to check is if nums L is equal to 0, then we can say k plus equals 1. And why are we doing that? Well, we're saying if the left pointer is a 0, well, when we inevitably shift the left pointer, we're going to be regaining 1 from our k allowance. So we're going to increase k back to what it was before we used the allowance for the current number that we are at, whether that be a 0, or it would be a 0 actually. And so this is only in the case we only want to shift our left pointer if k is less than 0, because in that case we've used more threshold than we're allowed to, and then we want to shift our left pointer. But we always want to shift our right pointer on every iteration. And so what about our result? Well, our result we can set equal to the maximum of our result and r minus l, so that's going to be the size of our window. So that's going to be the result, and then we can just return our result once we've completed our while loop. So let's submit our code and let's check it works. And it does. We see that we pass all 60 test cases for this problem. So it's quite a simple problem compared to a lot of the other kind of sliding window-esque problems, but it does require some thinking, and the key really is to think of it without this condition of flipping at most k zeros and then factor in that afterwards. So in terms of time complexity, guys, we're going to be looking at a big O of n, time complexity, big O of n, and space complexity is going to be big O, I should put parentheses after, big O of 1. So that's time complexity, and that's a space complexity. So I hope you guys enjoyed this video and found this video useful, and I'll catch you in the next one.